find the number of cubic polynomials p of x equals x cubed plus ax squared plus bx plus c, where a, b, and c are integers between -20 and 20, such that there's a unique integer m, which is different than 2, with pm equals p2. So pm equals p2, so this part is telling me that px minus p2 should have x minus m as its one of its factors. So px minus p2 should be x minus n times q. So let's work px minus p2. So px minus p2 equals x cubed minus 2 cubed plus a parentheses x squared minus 2 squared plus b x parentheses x minus 2. So using difference of powers and pulling out x minus 2 yields everything equals x minus 2 parentheses. The first term has x squared plus 2x plus 4 as its second factor, and the second term has a parentheses x plus 2, and the third term has plus b. And let's write the second term in a more organized way. So everything equals x minus 2 parentheses x squared plus x parentheses 2 plus a plus parentheses 2a plus b plus 4. Right. Now, I know that x minus m is a factor of this part. Let the other factor be x minus d. So after I expand and equate the coefficients, I obtain negative m minus d equals 2 plus a. This is the coefficient of x. Okay. So since m is integer and a is an integer, so is d. So d has to be an integer as well. That means d is another root of this quadratic. And since m is unique in that sense, there are two possibilities for d. D is either m or it is 2. So let's work those two cases separately and figure out how many a and b we can get. So let's start with the case when d equals m, and then the polynomial x minus m squared should be this quadratic, and when we equate the coefficients, we obtain negative 2m equals 2 plus a, and m squared equals 2a plus b plus 4. All right, so let's work it out. So from here, we obtain m equals negative 2 plus a, parentheses 2 plus a, all over 2. And let's square this and obtain m squared equals 2 plus a squared over 4. And let's set this quantity equals to this quantity and solve for a and b. So we get 2 plus a quantity squared all over 4 equals 2a plus b plus 4. Multiply both sides by 4 and expand it and obtain 4 plus 4a plus a squared equals 8a plus 4b plus 16. And subtract 8a from both sides. And observe that left-hand side is a minus 2 quantity squared. So a minus 2 quantity squared equals 4b plus 16. Since right-hand side is an even number, a has to be even. So this tells me that a is an even number. Let's write a is 2 times capital A, where capital A is an even number. Now, since a is between negative 20 and 20, this is telling me that capital A is between negative 10 and 10. Okay, and it's the first thing. The second thing is, if I substitute 2a back into the equation and divide by 4, I obtain A minus 1 quantity squared equals B plus 4. Okay, and now A minus 1 squared is always greater or equal to than 0, and B is at most 20. So B plus 4 is less or equal to than 24. That means A minus 1 squared is at most 24, which means A minus 1 square is at most 4 square, and this tells me that A minus 1 has to be between 4 and negative 4. Or A is between negative 3 and 5. So from here, we obtain 9 solutions. But we have to be careful. We need to rule out, or we need to exclude the solution that corresponds to m equals 2, right? So since we know that, okay, so we need, let's exclude m equals 2. We know that m equals negative a plus 2 over 2, and this is not equal to 2, means a is not equal to negative 6, or capital A is not equal to negative 3. Okay, so that we need to exclude the case when a equals negative 3. So here we need to subtract 1. So 9 minus 1 is 8, is the actual number of solutions that is coming from the first case. Okay. All right, so let's work the second case here. I'm going to separate the first part from the second part. So let's write down case 2, and d equals 2. And in this case, x minus m times x minus 2 has to equal to this quadratic here. And after we equate the coefficients, we obtain negative 2m equals 2 plus a. And I'm sorry, this was not correct. It should be negative m minus 2 equals 2 plus a, and 2m equals 2a plus b plus 4. So let's work those two equations and solve for a and b. So from the first equation, I obtain m equals negative a minus 4. And when I double it, I get 2m equals negative 2a minus 8. Okay, and then just I set those two equations equal to each other. So I obtain negative 2a minus 8 equals 2a plus b plus 4. And when I add everything, when I move everything to the right-hand side, I obtain 0 equals 4a plus b plus 12. And since those three numbers are multiples of 4, b has to be a multiple of 4. So let's write b equals 4 times capital B. Now, since b is between negative 20 and 20, capital B has to be between 5 and negative 5. Okay, and then after we substitute 4b back into the original equation and cancel out 4s, we obtain 0 equals a plus capital B plus 3. Okay, now for each b between negative 5 and 5, we get a unique a where this equation holds, right? So from here, we have 11 solutions. But we have to be a little bit careful. We need to rule out the case when m equals 2. So we need to make sure that m is not equal to 2. So let's write down the relation between a and m, which is here. So that means this is indeed negative a plus 2, negative a minus 4. I'm sorry, negative a minus 4. Negative a minus 4. So that means we need to rule out the possibility that a is negative 6. And in this case, a is negative 6 corresponds to b is 3. So b cannot be negative 3. I'm sorry. Actually, a is negative 6 corresponds to b equals 3, right? Yeah. So b cannot be 3. So that means we need to exclude this one. So from those two, we get 11 minus 1 is 10 plausible solutions. So when we combine the first two, we get the final answer. So let's write the answer here. So the answer is, for A and B, there are 8 plus 10, 18 solutions. And for C, there are 41 solutions. C can attain any value. Then this will not change anything. And so the answer is 18 times 41. And this is 738. So our final answer is 738.